In this video, we will give surprising and interesting theorem, Steiner-Lehmus Theorem. So this one, Steiner-Lehmus Theorem. This theorem is interesting because it gives relation between the bisector and the isosceles triangle. We will give a geometric proof for this theorem. There are many proofs actually in the literature, but some of them are indirect proofs, and some of them use some other topics like trigonometry. So we will give a pure geometric proof for this theorem. So we will begin by lemma, because we will use this lemma in the proof. So consider this lemma. Lemma tells if a triangle has two different angles, then the small one, the smaller angle, has the longer bisector. So let me draw the graph. So we have this triangle, and put this corner as A, B, C. So we have bisector here. Let's say this one and this one. So it has, so let's put here D and E. So it says if the angle B smaller than angle C, okay, let me put in this way, then the BD, which is bisector of the B, is bigger than EC. So this is our conclusion. So first let me prove this one. So let me draw the graph here again. We have this triangle. So this corner A, B and C. So this is the bisector for the B. So this is the bisector for the C. So this part is okay. This 1/2 B. This one also is 1/2 B. So this part is 1/2 C. So let me draw another line segment here, connect here. So this part we can say will be 1/2 B, because the angle C is bigger than the B, so we can write this. Now let me put this, okay, this BD, this part, this one was E, and let me put here F. Now you see we have this one, the angle FCB is equal to angle E, B, and D. So these tests, these points B, E, F, and C are okay, these points lie on a circle because these angles is getting corresponding to the same arc part, so that's why they are equal and they lie on the circle. Now let me remind you one observation. Now let's say you have chord here, this chord, and let's say our center is here. So if you grab another one, let's say this one, you see this is longer than the above one. So it means also if you have this angle, let's say this half, let's say, okay. So let me choose. So you see this one. So this chord is smaller than this chord, this one. Also, it's correct if the angle is bigger than the other angle. It means the corresponding chord will be bigger than the other chord. You may say this is center angle, but we can say the same for the other angle. Because in that case we have half of the arc segment. So these are observations is correct for the both cases. Okay, now we back to our proof here. Okay, now we can write this one. The angle B is smaller than 1/2 B plus C. Why? Because if you have 1/2 B, it will be same, but C is bigger than the B, so it means we are getting bigger angle here. Also, we can write this one B plus C plus A, because this is bigger than the previous one. Also, this test, our angle should be smaller than the 90 degrees. Now, if you write this angle again, the angle CBE is smaller than FCB. Okay, let me put in this way. And in the above conclusions tells us this will be smaller than 90 degrees. Now, consider the observation here, this one. If you look at this CBE is smaller angle, so it means CBE. So it means EC. So EC is smaller than FCB. So it means FB. But FB is smaller than BD, right? So it means EC is smaller than BD. So this one, okay, let's BD bigger than EC. So this one tells us that BD is bigger than EC. So we proved this lemma. Now we can state and give a proof for the Steiner-Lehmus theorem. So let me write again, Steiner-Lehmus Steiner-Lehmus Theorem. So it tests any triangle that has two equal angle bisector is isosceles. So any triangle, if it has two equal bisector, then it will be isosceles triangle. So let me draw again. You have this one. So it says if this is bisector and this one is bisector. So let's say A, B, C, D and E. So it says if ED equals, no, not ED, BD, right? There is no ED here. EC equals BD, so it means the angle B equals angle C. So this is our assertion. Okay, now let me give you proof. Actually, we will use the above lemma, so it will complete the proof. So we will use the contrapositive. For what does it mean? It means if angle B is not equal to angle C, then EC is not equal to BD. But this one, we already showed it, right? If this B and C are not equal, and B is smaller than the C, then the bisector will be longer than the other bisector. So we actually proved this idea. So after the writing this form, proof, it is clear from lemma. So there is nothing to prove here. So our proof is now complete. You see, this very nice proof.